Hi again. So at this point, things that you should have seen already in the content browser, you should have looked at the note and the video on the scientific method. You should have watched the YouTube video on accuracy versus precision, and then you also should have read through the lab report. So this is going to be your project that you're doing for this first day. It's going to be your project that tests your scientific inquiry skills. So we're going to be conducting this in class, but this is for those of you that are staying home or those of you that are online learners. So we're going to be doing something called a Whirlybird experiment. So your purpose of your lab, you want to determine the factors that impact how long a whirlybird can fly. So what I'm actually going to do first, so we have a visual, is I'm going to show those of you at home how to make a whirlybird. So all I have is a scrap piece of paper here. You can use a big piece of paper, you can use a small piece of paper, you can use a heavy piece of paper, a light piece of paper. That's really up to you, and that's part of the experiment is different factors. So to make a whirlybird, all I'm going to do is I'm going to cut a slit almost halfway up the paper. So notice I didn't go totally halfway up the paper. I stopped a little bit short of halfway. Next up, I am going to cut a slit here, and I'm going to cut a slit here. Now notice that I didn't go all the way through, right? I didn't cut this paper in half. I didn't go all the way through. I left a little spot in the middle. So now you are just, I'm going to try to do this towards you. You're going to fold one side in. You're going to fold the other side in. And to make sure that these stay folded, I'm just going to pinch at the bottom here, make a little nose. And now we've got our whirlybird. So if you see, this kind of looks like a little helicopter. If you think about those trees with the helicopters, that's essentially what a whirlybird is. So when I say fly, if you actually take your whirlybird and you drop it from up high, you're going to notice that it's going to spin around and it's actually going to fly. So let's pick that up from the ground. If you drop it low, it's really not going to fly. It's going to drop right down. But if you drop it from a really high height, the higher you drop it from, the more rotations it's going to spin and the more time it's going to spend in the air. So what you're doing is in this experiment, you are trying to determine the factors that impact how long the whirlybird can fly. So you're trying to impact the factors that will allow the whirlybird to stay in the air longer. So there's a bunch of different factors that you can manipulate. Really important, we're asking you to only pick one though. Don't pick all of these. There might be another one on here that you want to test that's not on this list, that's fine, but only pick one factor. So one factor you could choose is the length of the tails. So you could actually, these are the tails, so you could actually change the length of the tails by making them longer, by taping more paper there, or by making them shorter and cutting them off. That's one variable that you could change. Another variable you can change is the weight. So you could use different weights of paper. You could use heavy paper, you can use light paper, or if you don't have different kinds of paper, you can just use a paper clip. So you can put a paper clip on the nose of the whirlybird. That's going to make it heavier. You could also change the width of the tails. So you could cut the tails shorter here on this side and on this side. You could change the nose. You can change whatever you want. So essentially you want to change one thing and you want to try to keep everything else the same. So you're going to have two variables, whatever variable you picked, and the other variable that you're going to have is the length of flight time of your whirlybird. So now you want this to be consistent. So what you want to do is you want to pick a spot in your house that's a certain height, and you always want to drop your whirlybird from that height. You want to be as consistent as possible. So maybe you have a tape measure at home and you measure 6 feet. Maybe you use the length of a door frame, but you always want to drop your whirlybird from the same height, and you want to have the ability to time it. So preferably if you have a phone's a great way to time it because it's got the stopwatch on it. If not, you can use a clock, and worst case scenario, you can just count. This one's not great though because it's really hard to count at a consistent pace. So one variable is going to be whatever you picked here. Your second variable is going to be how long it takes a whirlybird to actually fall from that height. You then want to form a hypothesis. So you want to use the if-then statement. So you might choose to change the weight. So if the weight of the whirlybird is heavier, then the flight time will be longer. If the weight of the Whirlybird is heavier, then the flight time will be shorter, right? So you want to use the if-then statement with both of your variables. You're then going to go through your experimental design. So your experimental design is going to be you describing to me exactly how you are going to have this experiment. So two really important things. You want to be sure to only change one variable. The variable that I'm going to demonstrate for you now is going to be the tail length, just because it's the easiest one. So once you've picked your variable to change, you then want to figure out 3 ways that you can change it. So let's go through this. This Whirlybird that I just created is going to be what's called my control. This is like my normal Whirlybird that I made. This is going to be what I compare everything to. So this is my control. One change that I could make to wing length is I could cut off 1 centimeter. So if I cut off 1 centimeter, this Whirlybird is now 1 centimeter shorter than my control. A second way I could change it is cutting off a 2nd centimeter. And then a third way I could change it is by cutting off a 3rd centimeter. So what I've done is I would have had my control Whirlybird. I would have had then 3 different lengths of tail lengths. So that's really going to let you go through and measure really accurately how much tail length is going to impact the rate of flight for the Whirlybird. Once you've figured out your experimental design, you then want to list the materials that you used. In your materials section, please only list the materials that you used in your experiment. So if you didn't use paper clips, don't put paper clips. If you didn't use a meter stick, don't put a meter stick. If you use something not on this list, make sure you're listing your materials. This procedure section, this is how you're actually going to go through and measure it. But when you submit your lab report, I want you to submit your procedure. So you're going to use this as directions. That's great. But when you submit your lab report, you're going to submit your own procedure. I know procedure was in the lab handout, but I want to go through a really good procedure now. So a procedure is always going to be a numbered list. A procedure is a set of instructions on how you created your lab. And a procedure is always going to be in the 3rd person, not the 1st person. So you literally want to walk me through every single step that you took. So you want to walk me through that step when you had just a blank piece of paper in front of me. So tell me what, if I have a blank piece of paper in front of me, how I'm going to actually build your Whirlybird. If you can describe that in words, great. If you want to include a picture, that's also fine. So your first part of your procedure, your first part of your numbered list should be how I'm actually going to build my Whirlybird. Make sure it's always in the 3rd person. So don't say, I took my piece of paper and I cut it in half. You would want to say the piece of paper was cut in half. Don't say I folded the outside in. Say that the piece of paper was folded into thirds to create the Whirlybird. So it's always going to be in the 3rd person. The next thing that you want to describe in your procedure is the changes you made to the Whirlybird. So tell me how you got your 3 different Whirlybirds to look different. So for example, in my procedure, I might say 1 centimeter was cut off the length of the Whirlybird tails, and then flight time was measured. And then in the next step, I would say another centimeter was cut off the length of the Whirlybird, and then flight time was measured. After you tell me how you've changed your Whirlybird, you want to make sure you describe how you measured flight time. So you want to be as specific as possible. Tell me if you used a stopwatch. Tell me if you just counted in your head. Tell me how you dropped the Whirlybird. Tell me from how high you dropped the Whirlybird from. So you want to tell me literally every step that you took in your experiment to actually figure out how long this Whirlybird stayed in flight. Next up, you're going to have a results section. So in your results section, what you want to do is you want to tell me 5 different measurements for each Whirlybird. So your original Whirlybird, that was that control. That was that Whirlybird before you made any changes. That was just the normal one you built. So you want to actually drop that Whirlybird 5 different times and measure how many seconds it takes to hit the ground 5 different times. You're then going to find the average of those numbers. Remember the average, you just add up the total and then you're gonna divide by 5. What this is gonna do, if there's a really kind of weird trial, if there's one that falls really quickly because maybe you didn't hit your stopwatch soon enough, or if there's another one, if a gust of wind comes in the room and it takes a little bit longer, by averaging it, it's going to eliminate those strange ones, the ones that really don't make sense, and it's going to give you a more accurate number. You then want to go through and you want to make your first change to your Whirlybird, and you're going to take 5 flight measurements. You're going to make your second change to your Whirlybird, and you're going to make 5 flight measurements. And then you're going to make your third change and 5 flight measurements. Remember, you're not making 3 different changes. You're not changing the length and then the weight and then the width. You're only making 1 change in 3 different ways. Next up, you want to go through and you want to communicate your results. You're going to do that in your discussion section. So the first part of your discussion section, you're going to tell me if your hypothesis was correct or incorrect. So tell me what your hypothesis was, and based on the data, do you accept or reject your hypothesis? You then want to go through and you want to make sure you tell me that you can identify your variables. So tell me which variable you modified. Was it the length of the wings? Was it the weight of the Whirlybird? And tell me why you used a control. So I kind of mentioned it in this video, but tell me why you think it was important to use a control. You then want to identify, were there any other variables you changed by accident? So you're only supposed to change 1 variable. Were there any others that you changed by accident or that you couldn't control? And then you want to list the variables that were changed and tell me which ones you were unable to control, and make sure that you list your independent and your dependent variable. Last bit of your discussion, you want to go through and list potential sources of error of your lab. So a lot of students think that by telling me a source of error, you're actually making your lab design weaker. You're not. Every single lab that you do is going to have sources of error, things that you can't control. So by you telling me what the sources of error were in your lab, you're helping to identify things that could have gone wrong or might have gone wrong, and then even better, suggest how you might change that for next time. So what went wrong in your lab? What couldn't you control? And next time you do the experiment, how might you actually control it? In terms of marks, your rubric is at the bottom here. So you're going to get marked for a title page. Make sure you have a title page with your name and a really descriptive title. You're going to get 2 marks for your purpose, 2 marks for your hypothesis. You're going to get 2 marks for what's called your execution of your execution of your experiment. So execution of your experiment is just how well I think your experiment was designed. Did you only change 1 variable? Did you accidentally change more than 1? This should say procedure, so I'll change that by the time that you see it. This is going to be you writing out your procedure. This is worth a lot of marks, so make sure your procedure is a numbered list and it explains exactly how you did your experiment. Don't just copy and paste the procedure above. Your results, you can use the chart that I gave you and just make sure you record your own results. And then you want to make sure you answer your discussion questions. I did give you a template. This is just a Google Doc. So if you want to make a copy of that Google Doc and edit it, feel free to do that. Or you can do this in a word processor. And then once you're ready to submit, you're going to submit it to the Dropbox. If you have any questions or if you want to run some ideas by me, please let me know. Send me an email. And otherwise, good luck in your first experiment. Have a great day. See you later.